guys, so in this video, we're going to just introduce 5.3, which is all about solving trigonometric equations. So we're going to start off with a warm-up. First warm-up, you're going to have your unit circles out for this. So go ahead and get your unit circle out for this. And we are going to draw a quick circle. So right here, I'm going to use this circle as my unit circle. In fact, let me make the screen a little bit bigger. Okay. All right, so first thing, I have sine of theta is equal to half. So what this is really asking, if I were to ask myself, like in words, what is this question saying? It's saying, hey, what angle or angles, so what angle or angles gives a y value of a half, of one and a half, not one and a half, of a half. That's really what this question is saying. So using my unit circle, I want to go ahead and identify, hey, when do I have y values of a half? Well, I have y values of a half here, and I have y values of a half here at pi over 6 and at 5 pi over 6. And so my answers here is that theta would equal pi over 6, and it would equal 5 pi over 6, except I want to answer this generically. So I want to say, hey, if I were to technically graph this, I would have infinite solutions. I would have pi over 6. I could go all the way around the unit circle and say 2 pi plus another pi over 6. I could go around the unit circle once, and then I could go around twice, and then I could say 4 pi plus pi over 6. So there are infinitely many solutions here. And so the way that I can represent infinitely many solutions, or what is called a generic or a general, the way I can represent a general solution is to write my answer, which is pi over 6, plus the period of my function. The period of sine, hopefully remember, is 2 pi, times this letter n. And we say that n is an integer. It's any integer. So an integer is just like a whole number. It could be negative, it could be positive. And so my solution is going to be any iteration of pi over 6 plus 2 pi. I could add 4 pi, I could add 10 pi, I could subtract 24 pi. All of the solutions are represented there. In fact, if you were to graph this on Desmos, you would see that there are infinitely many solutions to this. All right, next question. 1/2 sine of theta is equal to negative radical 3 over 4. What I'm going to do is I'm going to multiply by 2 on both sides to cancel this 1/2 out. So what I'm left with is sine of theta is equal to, well, if I have negative radical 3 over 4 times 2, using a little cross simplification, I'm going to get negative radical 3 over 2. Well, negative radical 3 over 2 is a number that's on my unit circle. In fact, if I want to find out, and let me write this one more time. This question is saying something really similar. It's saying, what angle or angles give a y value of negative radical 3 over 2. That's really what this question is saying. Well, when I have a y value of negative radical 3 over 2, looking at my unit circle, it happens here, and it happens here. So if I think about where that happens, it happens at 5 pi over 3, and it also happens at 4 pi over 3. So my answers here, I want to write these generically. I'm going to try my best to write these generically. So to give the general solution, what I'm going to say is my first solution is that theta is equal to 4 pi over 3 plus the period of sine, which is 2 pi times n. That's my first solution. Second solution is going to be 5 pi over 3 plus any iteration of the period, which is still 2 pi. So I'll say plus 2 pi n, and that right there is my generic, solution. It's called a general solution to this question. All right, let's go on and let's practice something new. All right, before we start though, I just want to go over some general guidelines. So when solving a trigonometric equation, you want to solve the equation using your unit circle as your guide. So remember that the unit circle only gives us a picture of something between 0 and 2 pi. So my unit circle is kind of restrictive. It only gives me what are called specific solutions, and it only gives me, basically, if I go all the way around, that's 0 to 2 pi. Okay, You want to determine the period of the trig function you're solving for. So if you're solving for sine, its period is 2 pi. If you're solving for cotangent, that period is pi. You want to apply the period to your solution to create a set of solutions, which is also known as a general solution. Note that if you get a solution with answers in all 4 quadrants, you might be able to better simplify your general solution by identifying duplicate sets. All right, so the first question I want to work on is the question about collecting like terms. So for collecting like terms, I think I'm just going to, I'll just copy and paste it over. See if I can do that. Yeah. All right, so the first question that I have is this right here. And I have cosine plus 1 is equal to negative cosine. So I want to collect like terms on this. So what I'm going to do is I'm going to put all the cosines on one side and all the numbers on the other. So I'm going to add cosine to both sides. So we'll say plus cosine of x plus cosine of x minus 1 minus 1. So what I get is cosine of x plus cosine of x is 2 cosine of x is equal to negative 1. I'm going to divide by 2 on both sides. And so what I get is cosine of x is equal to negative a half. All right, so if cosine of x is equal to negative a half, what I'm really asking, what the question here is really saying, is what angle or angles, so what angle or angles gives an x value, so think x is cosine, of negative 1/2. Okay, that's really what this is saying here. So let's get our unit circles out and let's see, hey, when do I have an x value of negative a half? When do I have an x value of negative a half? Well, I have an x value of negative a half, what looks like here and what looks like here. This is happening at, let's see, 2 pi over 3, and it's happening at 4 pi over 3. So when I have an x value of negative a half, we can say generically, x is equal to 2 pi over 3 plus the period of cosine, which is 2 pi, times n being just an integer. We also get that x is equal to 4 pi over 3 plus 2 pi n. And that right there is my general solution. So that right there is going to be my general solution to this question. All right, let's go ahead and let's move on to the next question. All right, so these are questions involving factoring while I solve with trig functions. I'm going to go ahead and get everything to one side for a minute. So I have 3, I'm going to have 3 sine of theta plus 2 sine squared theta minus 1 is equal to 0. I'm going to kind of move this so that I have the biggest exponents on the left and the smallest on the right. So we have 2 sine squared theta plus 3 sine of theta minus 1 is equal to 0. So if you can see this and what it's going to factor to now, great. What I'm going to do is I'm actually just going to rewrite this in terms of just like, instead of saying sine, I'm going to say s. So this is the same thing as 2s squared plus 3s minus 1 is equal to 0. So to factor this, I'm going to go ahead and draw my box, and I'm going to draw my x. I'm going to put the biggest exponent in the upper left, so that's 2s squared, and my smallest in the lower right. If I multiply them together, I get negative 2s squared. So I want to know what multiplies to negative 2s squared and what adds to 3s. Well, there's really only a couple factors for negative 2s squared. And I want to know which of these is going to add to 3s. In fact, I'm looking at this now. I actually want to make this plus. I'm sorry. I think I messed this up. Yep, I was supposed to move it over by saying plus. Sorry about that. So we're going to say this is actually positive. All right, so what multiplies to positive 2s squared and adds to 3s? Well, 2s times 1s. 2s plus 1s is 3s, and 2s times 1s is 2s squared. So I'm going to just go ahead and put those in the box, 2s and s. All right, so if I go ahead and multiply these out, I want to know what multiplies to get 2s squared. 2s times s. 2s times what is 2s? That's 1. S times what is s? That's 1. And so this factors to 2s plus 1 times s plus 1. And if you already knew how to do that without doing that, awesome. I'm going to go ahead and replace s with what it is. It's sine. So we'll say 2 sine of x plus 1 times sine of x plus 1. So what I want to talk about real quick is what's called the zero product property. If I have a function, a times b is equal to 0, either a equals 0, a equals 0, b equals 0, or both equal 0. That's called the zero product property. So what I can do here is I can set both of these factors equal to 0, and that's going to be my solution. So I'm going to set 2 times sine x plus 1 equal to 0. And I'm going to set sine x plus 1 is equal to 0. These are going to give me my solutions. So what I get is 2 sine of x is equal to negative 1. And so sine of x is equal to negative 1/2. Here, sine of x is going to equal negative 1. So on my unit circle, I want to figure out, all right, when does sine of x equal 1/2? Negative. Well, sine of x is going to equal negative 1/2. It's going to happen here, and it's going to happen here. So it's going to happen at, 7 pi over 6. It's going to happen 7 pi over 6, and it's going to happen at 11 pi over 6. So generically, we can say x is going to equal 7 pi over 6 plus the period of sine, which is 2 pi n. And it's also going to be 11 pi over 6 plus 2 pi n. And then I just want to know, when does sine of x equal negative 1? Well, sine of x equals negative 1 right here at pi over 2, at 3 pi over 2. And we can see that its ordered pair is 0, negative 1. So x is also going to equal 3 pi over 2. So 3 pi over 2 plus the period, which is 2 pi n. And so my solutions generically are going to be x is equal to 7 pi over 6, 11 pi over 6, and 3 pi over 2 plus 2 pi n. All right, I think we have time probably to do about one more. All right, so using quadratics. Let's go ahead and see if I have a good one for this one. Yeah, let's go ahead and try this. So this will be the last one we kind of end on. Let's see if I have cosine. Oops. If I have cosine squared x plus 2, not 2, plus 4 cosine x plus 2 is equal to 0, I want to know what must the solution be. So hopefully we can kind of see here. I have something squared plus 4 times something plus, I don't want to say 2, sorry. I want to say 4 plus 4. If I replace cosine with a c real quick, just to make this more easy for us to see. I have c squared plus 4c plus 4. So basically, what multiplies to 4 and what adds to 4? Well, 2 times 2 adds to 4, and 2 times 2 multiplies to 4, and 2 plus 2 adds to 4. So this actually, just to kind of skip some steps here, this is going to be c plus 2 times c plus 2 is equal to 0. If I replace it, I get cosine x plus 2 times cosine of x plus 2 is equal to 0. If I set these both equal to 0, they're going to be the same thing, so I'm just going to set 1 equal to 0. So cosine x plus 2 is equal to 0. And so I get cosine of x is equal to negative 2. All right, so negative 2 is not going to be a value on my unit circle. So what I need to do is I need to use a little bit of inverse trig. This lesson is really not going to be about inverse trig, so we're not going to worry about it until the next lesson. So that's really all I have for you guys today. So just kind of to recap, the biggest thing about today is using the unit circle to determine a solution. So I know we've usually just had like one solution in the past, but notice here how we had 3 solutions here, 2 solutions here. In fact, we can have upwards of 4 solutions in these problems. All right, so I hope you guys have an awesome weekend, and we will talk more about this on Monday and Tuesday.